Hello everyone. In this video, I'm gonna talk about filtering in the frequency domain. I will start with Fourier Transform. By using Fourier Transform, any function whose area under the curve is finite can be expressed as the integral of sines and cosines multiplied by a weighting function. The 2D Fourier transform of 2D function is defined by this equation. Because we are dealing with 2D discrete images, we will use 2D discrete Fourier transform, which is given by this equation. We can go back to the original function by the inverse discrete Fourier transform. Because the discrete Fourier transform is complex, it can be expressed in polar form, where absolute value f uv is the Fourier spectrum, and phi of u and v is the phase angle. Now let's move to Visual Studio. The performance of Fourier transform depends on the image size, and it tends to be faster for image sizes that are multiple of the number 2, 3, and 5. So we path the image to meet these conditions by using get optimal DFT size and copy make border. Here we define mat called planes, consist of two mat, one for real values and the other for complex values. Because the result is complex numbers, we will display the magnitude image of the transformation. Because of the large dynamic range of the result of Fourier transform, we will scale the magnitude image. Finally, we need to center the Fourier transform to the origin of the image by swapping the 1 and 4 quadrants and 2 and 3 quadrants. Thank you for your attention.